Okay, so we were talking about the fact that the greater the value of the capacitor implies that we can have a perfect DC waveform at output. So why not we always choose the greatest possible value of the capacitor to achieve the uh, exact DC waveform at output. So there are a number of issues associated with this value of capacitor, greater value of capacitor. First of all is the peak value of the current will increase. The RMS value of the current passing from this diode that will also increase, and the surge current will also increase. These are known facts, but why? Why is it that with increasing the value of capacitor, the peak, RMS and surge value will increase? So consider the circuit shown in figure 3, in which there is an AC source, a diode, and a load has been attached, and some output filtering is being done. So let's move on towards next slide. Results in case of no capacitor attached. In figure 3, the capacitor was showed to be 100 microfarad, but when the first result was obtained, in that case there was no capacitor attached. The result obtained in that case is shown here, in which you can see that VR is the waveform across the resistor, I1 is the current from the diode, and the conduction time of diode is labeled as T old. If you see here, the time period T old is approximately 0.01, it is 10 millisecond. The input signal frequency was kept as 50 Hertz, so the only half cycle has been rectified. You can see that the voltage VR obtained at output, and I1 input the current from the diodes are exactly in phase. It is because resistance, our load is resistive, and the conduction time of diode is 180 degree. It is 180 degree, which means that from 0 to if we consider that this is 0 and this is our pi, and this is pi to 2 pi. So only during this time period, this time 0 to pi, over this diode D is conducting, and the time period with respect to this waveform is T old. Now result in case of a 100 microfarad capacitor. When we have used some capacitive filtering at output, in that case the ripple in output waveform is decreased. The peak value of the current from diode has increased. So this is the fact that I was talking about, that when we increase the value of capacitance, previously there was no capacitance, but now that I have attached some capacitance, the peak value of the current has increased. You see here it is peaking up to 3 ampere, whereas in previous cases the units are in volt and here in ampere. So previously it was exactly 1 ampere, and now it is 3 ampere. And also you can see that the ripple in the output voltage has reduced. In the previous case it was almost 100 volt, but now in this case it is from 20 to 100 volt, that is 80 volt peak, 80 volt delta V. The new one is 80 volt. Also you can see that the conduction time of diode has reduced. Previously this time period was exactly 10 millisecond, that is half of the exact half of the input signal frequency. So now let's move toward the case in which the value of capacitance has been further increased to obtain a DC near to DC waveform. So 1000 microfarad capacitor is now used, and in that case you can see that the ripple has further reduced. The ripple is now almost 20 volt. Is 20 volt. And if you see at the current waveform, you will see that the current has also increased. The current is now approximately 20 ampere, and this very first peak of the current, it is 30 ampere. This is this very first peak of the current that comes. It is known as the surge current. It is because we are considering that there are no initial no initial charges on our output capacitor, due to which a huge amount of charges will be required by the capacitor to completely charge itself. So the current has increased up to 30 ampere in the first case, and this is known as surge current. So the when we were previously talking about a number of factors, that is the IRMS, I peak, peak inverse voltage, and other different values, we have also mentioned I surge current. So this I surge current is very important to consider into our design. Most people, they go through all these calculation. They calculate the, or they determine the RMS peak value, peak inverse value of the current, but they do not consider the surge current rating of our diode that we are going to use in our circuit. You can see that even if the peak inverse value of the diode, RMS, average, and other all values are determined, and we select a device only on the basis of these. But if we do not consider the surge value of the current, and we just use a device that is completing the requirements of IRMS, I peak, and other values, what will happen? The very first peak that will come, that will damage our diode. So it is necessary and recommended that we also take care about this, take this value into our consideration. Okay, so now coming back towards the question that why the peak value of the current has increased, or the surge current, or whatever has increased. It is due to the fact that you can see that the conduction time of diode T nu, it has reduced. If you go to previous slide, on slide number 4, you see that this T old was exactly 10 millisecond, half of the time period of 50 hertz signal, but now the conduction time of diode has reduced. So here see that in case of no capacitor, the waveform at output was supposed to be like this. But if you see that now, due to capacitor, the diode is only conducting in this part, here to here, here to here only. The capacitor has reached to its maximum value 100 volt in the first cycle. Then what happens when the negative cycle comes?